Okay, in this video, we're going to be doing Calc Problem Set 76. The problems and a playlist are in the description below, and let's see what we got. Given that the integral from 0 to 4 of f of x dx is 6, find the integral from 0 to 2 of 3 times f of 2x minus 4 dx. So the first thing I do with this problem is I say to myself, the integral from 0 to 2 of sum or difference can be broken up into two integrals. So I'm actually going to break this up. I'm going to start with the original integral. And then I will break it up into, we're going to do 3 times the integral from 0 to 2 of f of 2x dx, and we'll worry about that in a second because that one's not as obvious, and then minus the integral from 0 to 2 of 4 dx, and that one we can think of just a rectangle that has a height of 4 and a base of 2. So we'll be able to get that one graphically, or just in your mind you can think that. Let's deal with this first one though. So here, I mean, the 3 is just going to hang out. It's really the integral part. So what I'm going to do is I'm going to say, instead of f of 2x, I'm going to say f of u, right? So u is going to be 2x, which means that 1/2 du is dx. And we have to change the bound. So if x is equal to 2, that means u is equal to 2 times 2, which is 4. If x is equal to 0, then u is equal to 2 times 0, which is still 0. So we can totally transform this given integral into a new integral that goes from 0 to 4. So the 3 is still there. The dx is 1/2 du, so I'm going to pull out the 1/2. Our bounds changed from, our lower bound changed to 0, which is still 0. The upper bound changed from 2 to 4, so we're now going from 0 to 4, f of u du, and then, minus that original one. Let's keep going and evaluate this one. So we're told that the integral from 0 to 4 is 6, and so we have 3/2 of 6. So that's 3 times 3, which is 9. Now I already said that I'm going to think of the second integral as just a rectangle. You could draw it if you need to, but it just has a height of 4 and a base of 2. So this is a rectangle that is 2 by 4, and so that means that this area is going to be 8. And so now what we have to do is the original integral is our green thing, which is 9 minus 8. And so 9 minus 8 is 1. Don't forget the minus sign there. I think that's probably the most likely place you would make a mistake after all of the things that you've done. But that's it. It's 1. Pretty good problem. Let's take a look at another one. Given that f of x is differentiable, so that's important because differentiability implies continuity, and continuity means that the limit exists, the function exists, the limit equals the value of the function. Kind of go through that every time I think that. With f of 5 is 3, f prime of 5 is 4, evaluate. The limit as x approaches 5, f of x minus 3 over x squared minus 25. All right, so because we're told differentiable, I need to kind of establish that I know the limit as x approaches 5 of f of x, but I definitely do, right? So f is differentiable, which implies that it's continuous. Therefore, the limit equals the value of the function equals 3. So we know that the limit is 3. That's important because it means the limit of the numerator is 3 minus 3, which is 0. The limit of the denominator is 25 minus 25, which is 0. This is a L'Hopital's problem. So I'm going to write that down. Limit as x approaches 5, f of x minus 3 equals the limit as x approaches 5 of x squared minus 25 equals 0. So we can use L'Hopital's. So therefore, by L'Hopital's, our original limit is going to be the limit as x approaches 5 of the derivative of the top, which is f prime, over the derivative of the bottom, which is just 2x. And now we know that f prime of 5 is given, it's 4. So now we have 4 over 10 because we substitute the 5, which is 2 over 5. That's our answer. Let's look at the next problem, which is not the last problem in this problem set. I kind of thought it was. All right, next problem. Number 3, the line y equals 4x minus 5 is tangent to y equals 3x squared plus ax. At x equals negative 2, find the value of a. These types of problems come up. They're not like tricky, but you just got to think. If I know the tangent line, then I know the value of the derivative. I also, in some way, know the ordered pair if I were to need it, but I don't think I need it. If I know the original function, I know another way of writing the derivative. Just power rule this thing. So remember, the derivative of a times x is just going to be a in this case because x is the variable. And what I'm saying is, if I plug negative 2 into dy dx, I should get the slope of the tangent line. I should get 4. So I'm basically saying that 6x plus a at x equals negative 2 should equal 4. Plug in negative 2, you get negative 12 plus a is equal to 4. which means that overall a is equal to 16. That's another, I mean, that's like a pretty straightforward problem, hopefully. Let's look at the next one. Given the integral from 0 to 5 is 8, from 3 to 8 is 15, from 0 to 8 is 20, we want to try to find from 3 to 5. All right, so I'm going to do this. I'm not going to like write out the integrals every time. I'm going to do this. I think of this as using just like, I think of them as bars of certain length. So for example, we know the integral from 0 to 8. I always start with the biggest one. So from 0 to 8, we know it's going to be 20. So I'll just draw what I'm calling a bar, and that bar is 20 units long. It doesn't matter if it's positive or negative. You can just like label it. It's just a concept that we're doing here. So 0 to 8. The next thing is from 0 to 5, I know the integral is 8. So I'm going to try to line it up so that zeros match up. And I'm going to put 5 where roughly I think 5 would go on the number line from 0 to 8. So say like this, right? Maybe 5 would be there. That has a length of 8. So we're not really being asked about it, but now I know based on this picture that if I wanted to go from 5 to 8, it would take 12, right? Because 20 minus 8 would be 12. That's the whole idea. Like picture them as actual physical things. And then I'm going to do 3 to 8 in kind of the same way, right? So 3 roughly where it should go, and then the 8s line up, and that has a length of 15. So because I know 0 to 8 and I know 3 to 8, I know that the difference from 0 to 3 should be 20 minus 15, which should be 5. So this length here should be 5, because now 0 to 3 plus 3 to 8 gives us 20. And then the question was, what is the integral from 3 to 5? Well, I now know that from 0 to 3 is 5, and from 0 to 5 is 8. So from 3 to 5 should be the difference. It should just be 3. So I think the integral from 3 to 5 of f of x dx is going to be equal to 3. That's pretty much how I solve them all the time. Like if I needed to write it out, I would now like think, okay, so I first did 20 minus 15. The 20 is the integral from 0 to 8. The 15 is the integral from 3 to 8. So I would write down integral from 0 to 8 minus integral from 3 to 8. You can see that that's going to take like a lot of writing. I mean, it makes sense if you have to justify all the steps, but I think that this picture helps you solve it right away, so I recommend it. All right, that's the whole problem set. I hope this was helpful, and good luck.